So we'll talk today about decentralized cooling. What's the potential? What are some pitfalls and how do we implement things in practice? I'm talking about cooling as such, so not only active cooling, but also other cooling technologies. So how will the day or this hour look like? Well, we have several speakers today. So I'm working at the Swiss Federal Labs as a senior scientist. Then we also have Bas, who's working at Wageningen University and Research, who will give a short presentation on the work he's been doing. Then we have Florencia of Efficiency for Access, and then we have David of Innovex. They all will give a short presentation on the work they're doing, their insights on indeed the promise and the pitfalls and the practicalities of cooling and decentralized cooling. And then we also have a Q&A. So I would urge you to ask questions in the chat when you have some. We would be more than happy to answer as much of those as we can. Good. That being said, I would like to give a short introduction on this session with respect to cooling as such. So first, to set the scene, which technologies do we have available and also how do they work and how can we select those? That's a short intro to the other speakers. And I mean, let me start with an image you might have seen already. These are typical solar-powered cold storage rooms. This is active cooling. A lot of smallholder farms put their produce there. There are many crates of many different people. This is a typical active cooling solution, which has now been deployed many times in many places already in the Global South, amongst others. Now, there are other solutions as well in the active cooling field. So we have these solar-powered cold room systems, but there are also, I call them do-it-yourself systems, where people have been installing in self-insulated, let's say, rooms, spaces, air conditioning units, for example, with the CoolBot technology, where they could actually also have some kind of cooling, which could help preserve their fruit, vegetables, but also meat and dairy products. Then people have also been experimenting with using, let's say, off-the-shelf refrigerated containers. This is a very large one you see in the image there, but also smaller ones, 20-foot containers, to also help to cool in an active way. Of course, then you need a power supply. There have been hybrid evaporative coolers, which the group of Erik Verploegen has been developing with this company CoolVeg, which work on active, a hybrid between passive cooling and active cooling by using evaporation of water. And then the things you might already know is that we can cool indeed with ice if we can produce it locally, and there are also smaller fridges we have been working with as well that can cool on a smaller scale. So actually, many active cooling solutions available for decentralized cooling. And apart from that, something which is less known, at least now, but it has been around, many of these technologies, for thousands of years. They have been used for thousands of years in many places in the world, is, for example, passive cooling technology. So it means you don't have an active cooling system in place. And that's actually rather important if you look at these different options which are available. You have, for example, there evaporative cooling. So by evaporating water, we can actually extract heat from the environment and also from our products and cool them without any supply of additional, let's say, electrical energy and so on. You can also cool using spraying in an evaporative way. And then people have been in some places in the world, it's possible to also cool using underground systems or cool during by night ventilation. So by using actually lower temperatures during the night, which should be available, and it's not available everywhere around the world, to drop the temperatures. So apart from that, we also have radiative cooling, and that's something which has been used around the equator for a long time, actually, even to produce ice, that you actually make use of the clear skies and the low temperatures in the night to cool down, for example, different surfaces or buildings even. And then we have also people that have been storing at the high altitude their products, and also people that have been using ice, snow, which have been harvested let's say, when it has been available in winter and then stored throughout summer. So these are passive cooling technologies which could also work. And apart from that, we have also something which is called, it's not a cooling technology, but it's, let's say, methods to prevent heat from coming in and to also modulate or steer a little bit the heat fluctuations during the day. And it's very relevant to understand this. And I just wanted to give a hint here. I mean, I will share a publication later where you can find more information. But if we want to cool, then we want to extract the heat which has been supplied to our building or whatever enclosure where we store our fruit inside or foods. But if we, for example, can reduce this heat coming in, then we can actually avoid the need for cooling to some extent. So here you see, let's say, an enclosure with, let's say, in this case, fruit inside, and we put all the heat sources coming from radiation, conduction, convection, which put the pressure on your enclosure where you want to store your foods to be cooled down inside. As I've talked about, there are many passive cooling technologies. You can have night ventilation, evaporative cooling, even cooling with ice and so on. But suppose now we can try to prevent heat from coming in, then actually we have a lower need for cooling. And you can do this in many different ways. I will not go into detail here, but you can, for example, protect due to shading, by shading your enclosure from solar radiation. You can also make sure that you don't produce too much heat inside the building by having fans which don't produce too much heat or not too much lighting inside. And of course, the logical thing to do is to insulate your enclosure very well. So these are preventive technologies, but they're not cooling technologies. You also have modulation technologies. For example, if you would ventilate with colder air to promote heat exchange, or if you would use thermal storage systems inside to prevent that your temperature in your room and also of your foods would then fluctuate during the day. So this is to give you a glimpse of all the tools we have actually available to, let's say, reduce our heat load on our products. The question is, of course, which technology do we choose? And that's a very important question. And what we often see is that there is a link between, let's say, the producer and the amount they can produce and the market they can reach. So, for example, if you have smaller farmers, they often don't have the capacity to reach export markets. So there is kind of a rather linear line zone where actually, which links actually the farmers and the produced capacity to the markets they can reach. So apart from that, it's also very important to note that some foods don't necessarily need active cooling or can also be kept for a certain amount of time under normal, let's say, conditions, under ambient conditions, depending on the temperature outside. Of course, cooling is always better, but cooling is not always super critical. It's even possible that with passive cooling technologies, you can already go a very long way because they help to reduce the temperature, but they don't reduce it to the ideal state. So you really have to think about, apart from the amount you have and the market you want to reach, does my fruit, vegetable, or other food need some type of cooling? So what we see is that, I mean, the technologies being used, for example, for smallholder farmers are more low-tech, or more traditional, amongst others, passive cooling technologies. If you then have people with a higher, let's say, higher volume, or if we can aggregate also products of different farmers together, then we have more access financially also to high-tech technologies. We can also reach them different markets. So we cannot reach an export market without, for example, active cooling. This is becoming very tricky. Now, there is a trick which we can pull, for example, to still have smallholder farmers reach further markets, and that's when we take into account intermediaries that would provide access to active cooling, to transport, and so on. So then it's possible, and we have seen this before, that smallholder farmers and their products can still reach, for example, export markets. So that's a trick we can do, but then we need intermediates to, let's say, facilitate this entire process. So a very important message here is choose the right technology for your specific use case, and we have been putting a lot of time into this, let's say, accommodating this selection process. So to start off this session and some take-home messages is really stressing that cooling is a very impactful way to extend the shelf life of your products. It does not need to be active cooling. You also have passive cooling or all these preventive and modulation technologies which are available. You have to really look at which scale do you need, which financial means do you have available, and also which energy supply is available. So it's really a very important selection process we have to go through. And it's very important to choose the best technology for your use case. If you choose the wrong technology, then sometimes it will end up not being used so much. So it's really important to do the work before you actually start. And a very important thing I want to stress is that actually we can combine technologies along the supply chain. So active cooling is one solution, but often it's actually good to combine different technologies there. So that being said, I would love to introduce the first speaker, and it would be great if this person could go into the room. Hi, Bas. So, Bas, would love to hear all about your experiences here in this field, and handing the word over to you. And after your presentation, we can have tackle a few questions to you. Thanks, Bas.
Thank you, Thijs, and I hope my presentation can be put on screen as well. Thank you for the moderator. So yeah, after Thijs gave a kickoff of the technologies being available, I will be doing a small deep dive into the viability of cold chains. And I want to start with a successful case, and this is at the Friends of the Kilimanjaro, which is a farmer cooperative, and they are having a decentralized cold room, fully driven on solar power, and they are storing green beans, which are meant for the export market. Have visited this site in 2 years ago, and it was operated successfully. However, that is not always the case. And in 2023, we already published a piece where we reflected on the secrets of unsuccessful and successful cold rooms. And why that was needed and still is needed is because a lot of cold rooms are not functioning today. This one is standing in Rwanda, in Kigali, was installed with the intention to store fruits and vegetables for a local market, but in the end didn't work. Why didn't it work? Because every day there was fresh produce being delivered to the market. There was an oversupply and less demand for the products. So there was no business case to store fruits and vegetables. And that case in Rwanda is not the only one. If we look, for example, in the dairy value chain in Ethiopia, we see that 180 tanks are installed and only 56 are used. That means that almost 70% of the dairy tanks are currently not in use, which is concerning. So that is why we are questioning, why are there so much white elephants? Or if we formulate it positively, how can we make sure that we have viable cold rooms? So looking into that, thank you. Looking into those white elephants, we see many aspects of what is not being addressed or what should be addressed to make it a success, which includes, for example, governance and ownership of the cold room, skills and capacity, market access, which will be addressed later in this webinar, but also technical over-design or under-design, but also often business models, wrong product market fit, so the viability of cold rooms. And I will dive deeper into the orange one, but know that there are many other aspects. So if we look to product market fit, we often talk about 3 elements, which is desirability, viability, and feasibility. That's often also a model used within startups. But if you plot that on, for example, the business model canvas, you see that desirability is about the value. And in cold rooms, that is about creating income, creating nutrition, reducing food loss and waste, or even getting a profit for the private sector. Do you look into the feasibility? We often see that you can buy cold rooms, you can build them yourself, like Thijs said, the more traditional technologies, for example, or you can borrow or lease it using, for example, cooling as a service. This is often related to the affordability of the technology. And then we have the question of viability. So can we make a business case around the technology? And we will dive into that, because the question is, if we have different crops, different products, different food products, do we have a one-size-fits-all approach with regards to the technology or not? And like Thijs showed, we often have to evaluate that question on the viability of cold chains on different markets. So the model Thijs already showed shows on the horizontal axis different markets in different sophistication levels, and on the vertical axis the sophistication of the farmers and the technologies. And what we see is broadly that you can divide them in 3 or 4 categories, which are informal, mid-level, and high level. And if we then look into, for example, 3 value chains, we chose dairy, poultry, and potato here, we can see that the viability of cold cooling is different in these 3 value chains. So if you, for example, look in the dairy value chain, already in the informal sector, you can see that dairy cooling is being used. That is because the high perishability of the product. So you often see the milk tanks being used and then delivering, or the milk cans being delivered to a milk tank, and then collection happens. And the more you move towards a mid or high level food system, you see more sophisticated technologies appearing. For example, cooling already in the hoses during milking and bigger tanks. But you also see that the sophistication of the production technologies increases. In the poultry sector, you see in an informal sector often that the chickens are brought to the market alive and being prepared on the market for consumption. And as soon as the market more goes into, for example, formal slaughtery, then you see particular cooling technologies being developed. And that's often driven not only by economic demand, but also, for example, food safety regulation. Animal-based products are subject to food safety regulations. So there's also a legal need to invest in cooling. And if you go to high-end markets, you see that space cooling becomes part of the equation as well. And that's the bigger slaughter lines we see. If you look into the potato sector, there you see that, for example, the passive cooling or evaporative cooling is often in place in the informal and mid-sector level. The cooling technologies only come into play when there's high-end demand. For example, if a processing factory is placed and you want to optimize the utilization of the factory. So here you can see that cooling technologies become available in different maturity levels of the value chain. And the next slide is even a further deep dive into that. So we studied multiple value chains and have reflected on the likelihood that cold chains will appear. Not saying it's off-grid or on-grid, that is something I will address in the next slide. So here you can see how likely it is that cold chains will appear, for example, in the beef sector, poultry, fishery, and dairy. That are the animal-based value chains. And what you see is that cold chains are viable often already from a mid-level sophistication. And that has to do with regulations. There's food safety regulations pressing on the need for cooling. On the right side, so more the vegetables and fruits, there you see that there is no mandatory, cooling is not mandatory, and therefore the viability is on a higher level because it's driven by economics. And also, for example, if we look at potato, we can see that ventilation is often a solution for storage as well. So it's really important to recognize when cold rooms are viable, because if you are designing a cold room program, for example, or cold chain program, you can see where to put attention to and not in accordance to the sophistication of the value chains in certain countries. And if you want to grow to the next level, it also implies you have to look into the production and the market if they are ready to make the same step as you will do in the value chain. Then the viability of off-grid cooling. We have reflected on solar-powered cold rooms as well, and when they are viable and not. What we see in the paper for substantiation of the claims is in the link below, which you will receive as well. So in the dairy chain, we see that there's a high viability. This due to the high perishability, but also the food safety regulations. That also counts for fish. But for fish, why is it relatively high and not super high? Is because fish you can preserve in different ways. You can also smoke it, keep it alive, fry it, dry it. So there are many ways to preserve. So you can see that as soon as the market becomes more formal, then the fishery sector is one of the first one to move with off-grid cooling, also because fish needs cooling directly after the catch, for example, with ice and active cooling. Another one are green leafy vegetables, herbs, peas, berries, because they are highly perishable fruits, vegetables, and they need cooling quite decentralized. So let's say within 1 hour after harvesting. Also relatively high because there are other ways of preservation, or say we bring them quickly to the market. So if you bring them quickly to the market, it's also often not needed to cool them to that extent. Then into the orange and red zones, for example, tomatoes, bananas, mangoes, is often the viability is low to medium, depending on the length of the value chain. Thijs already showed us that some products do not need cooling in the local market because they ripen after harvest. And we know that from a banana being green when we harvest it, turning yellow along the value chain. And poultry meat is a low viability. Why? Because it's often connected to slaughterhouses. So where there's already a bigger need for cooling, space cooling. So there the business case for off-grid cooling is lower, including potatoes and onions, based on the study we published below. So the 3 takeaways I want to give you is that there are many aspects influencing the viability of cold chain. I addressed the different products, different value chains, and the different needs for cooling. And there are also competing solutions, like Thijs mentioned, or alternative solutions. The last point is to thoroughly assess the viability and the need for cooling. We have published the post-harvest assessment methodology, which you can use to do that. Thank you.
Thank you, Bas, for this very enlightening presentation. I would love to ask you just maybe a question or two. If you would have a magic wand and you could change one thing now, which would have an impact on the future, what would that be, and in this context? It's a very challenging question, I know, but...
Oh, wow. If I had a magic wand, what I would change is the understanding of people in the viability or not of cold rooms. So we often see that people coming from different sectors and don't know what they don't know. So stepping into agriculture is quite complex. And if I had a magic wand, I hope that all the people have a little bit more knowledge on that and understand the complexities to kind of go through it. And of course, if I have a magic wand, I want everyone to have food and fresh food and things like that. But that is my big dream.
Good, thanks. And then I have another question for you. I mean, you hinted on this, on the different products and so on the different scales. Where do you see the highest real growth possible with respect to scale and product? So where do you see for decentralized cooling? I mean, you hinted already, it likely would be business case for fruit and vegetables. or in which regions do you see that you will have very high developments of, let's say, these cooling solutions for specific products?
Yeah, and I think I will go back to my slide here. What you see is that the more mature the market is, the higher the likelihood of cooling. And that purely has to do with economics, like the more people earn, the more they can spend on food, but also the more they buy for convenience. So in that sense, the higher the maturity of the market, the higher the chance, the viability of cold chains is there. On the other hand, you see that, for example, in the animal-based products, regulation is pushing for the need for cooling. So there you see that the viability already is in an earlier stage than in fruits and vegetables. So fruits and vegetables, that's also what we observe, right? When you go to Kenya, you see that there's a lot of export with cooling, or in Rwanda, and for domestic markets, there's hardly any cooling. And that is what we can kind of reflect on with this model as well. So I would say highest likelihood is the animal-based products in the general cold chain perspective, because there's regulation pushing for it. And then we have to look into where the markets sophisticate or in alternative models to make fresh fruits and vegetables available for communities which most need it.
Very good. Thanks so much for your presentation, for your talk. We will get back in the end for a Q&A. So I would love to introduce then the next speaker, which should be ready to go. So this is Florencia. So Florencia, hi. Thanks for joining. I would love to give you the floor to really show what you have been doing in this field, and looking forward to your presentation. So please go ahead.
Thank you, Thijs, and thank you for everyone and putting the presentation up. I will be talking now, following up from great presentations from Thijs and Bas, and I will be speaking about cold chain champion innovators. I am a researcher at Energy Saving Trust, who co-manages both the Efficiency for Access Coalition and the Low Energy Inclusive Appliances Program, alongside CLASP. And these two organizations focus on advancing high efficiency appliances to enhance energy access for off-grid and low-income communities. And within the program, one of our key activities is the Efficiency for Access Research and Development Fund. Through this fund, we support innovators to develop affordable energy-efficient solutions that improve energy access in Sub-Saharan Africa and South Asia. And within the supported organizations, which have been more than 38 up to date and over £5 million of funding, many of them have been focused on cooling solutions. So why I tell you all this context is because over the next couple of minutes in my presentation, I will be highlighting 3 grantees of our R&D funding and how their innovations have advanced off-grid cooling, specific for agriculture, what have been the main challenges that they have been facing, and what are still the barriers for them and for other innovators of cold chain for off-grid settings. So the centralized cooling, which is the focus of our panel. So the 3 challenges that I will be delving into through these 3 case studies of our grantees of the R&D fund are: first, product market fit, which Bas did a great presentation of the importance of this in providing cold chain solutions. And from the company's perspectives, to find a clear product market fit and make a successful business or a successful organization, they need to have clear understanding of their end users' needs and then link it with their value proposition. And they do this, or successful options, they have done this through research of their users and co-development of their business models and technologies with the users. So to really find a fit for purpose solution in these settings. The second challenge is related to complexity. Complexity can be many different things, but when I talk about complexity in this presentation, I relate to how companies in the off-grid setting need to many times create a systemic solution, since there is non-existent or very limited cold chain infrastructure where they're working, and create those market linkages that we talk about a lot. And I know that there will be a session ahead focused on it. And last but not least, affordability, which is still a key challenge hindering the deployment of cooling solutions. And affordability is addressed by many stakeholders in the sectors in different ways. But as we know, many chain solutions, specifically the active ones, require high investment. So technology and business model innovation need to work hand in hand to close this affordability gap and find the viable solutions for the specific value chains or contexts, as Bas was explaining very well in his last presentation. So to get into the case studies, first talking about product market fit. And I want to talk about a great example of an innovator who found, or who has found, their product market fit by really understanding the gaps in the value chains they're targeting and creating a solution that fills these gaps and where there is existing demand. This innovator is Savannah Circuit, who have developed products and services for the rural first mile of the dairy and fish value chain in Kenya. And when I say first mile in this context, is very close to the production. So for the fish value chain, very close to catchment, and for the dairy value chain, very close to production. How have they done this? They developed glycol-based cooling technology, which is a solar-powered hub which refrigerates water. This water glycol mixture that then is provided to portable vessels fit for each of the value chains. So for example, on the picture on the right below, we can see the milk cans. So the water glycol mixture refrigerates the milk can, and this is fit for the most remote dairy farmers. So as Bas was saying, even in an informal market for dairy, these couple of hours needed to refrigerate the milk at the production are very important for the smallholders to bring their milk without spoilage to the aggregator centers or to the cooperatives. And similar for fish, those couple of hours that the Savannah Circuit solution provides them has really improved their income, as they have had way less spoilage of their produce. And they have developed this technology through, as I was saying, the co-design and piloting of the technology with the end users. They work very closely with the communities in Kenya, and they have iterated their product many times and business model to really fit their target users. So how they've addressed this, aside from the technology, is also through flexible payment models, through cooling as a service, and leasing of, lease-to-own models with the portable vessels. Right now, they're still working on building local partnerships and increasing trust and demonstrating their product, which is a pilot, but they're going beyond pilot and trying to commercialize and scale this solution, which is very good for this specific product market fit, and they found this gap. The second case study that I will be briefly discussing, because we could talk for a full hour on each of these case studies, is regarding complexity, where a whole systems approach, as I was saying, sometimes is needed, or many times is needed, to develop an end-to-end off-grid cold chain. And Adili Solar Hubs is a case of a company who provides cold chain services for fishing communities in Lake Turkana. They have taken a whole systems approach, and they have done so many activities to provide cooling for the fisher folk and improvements for the community, but I will be talking about 4 specific points. First one is that they're located very closely to the source of the produce. They installed their cold hub close to Lake Turkana, where before there was no infrastructure for cooling, and their cold hub, which includes freezer rooms, chest freezers, and an ice making machine, provide ice for the fisher folk to cool their fish at catch, and then the other parts of the other technologies to act as an aggregator of fresh fish. So Adili Solar Hubs is the intermediator, as Thijs was saying in the beginning of his presentation. So they purchase the fish from the fisher folk, and then they sort it, clean it, process it, and freeze it to then sell it to different markets. And this has guaranteed income for fisher folk who before dried their fish for storage. And through this business model, fisher folk have seen a 5-fold increase on their product value. So a kilogram of fresh fish has a 5 times higher cost than the dried fish they used to sell. When I was talking about how Adili then sells the fish to markets, that's another key challenge they've had to address in a systemic approach, because they have created this new market of fresh fish, and retailers, even though they want to sell this new product, didn't used to have cold storage. Then Adili also is trying to address this by providing freezers, like solar-powered freezers, to retailers through a lease-to-own model. So as you can see, there's many pieces falling behind their model, and they've been successful as to now. They're really a great example to sell, and currently they're still working towards enhancing their capacity and finding other and diversifying other demands. The last thing that I wanted to mention about them is that through their cold hub, which they needed water, so they had a water treatment plant to create the ice. They also now provide water to the community and the school and the primary school of the community. So that's like really an encompassing approach to their model. And the last case study I will talk about, but last but not least, is Coolveg, who is addressing affordability. So as we were hearing in the last 2 presentations, there is still low uptake, or these white elephants, for off-grid solar cooling technologies. And there are many reasons for this, but one of them is affordability of the users. And as we were hearing also from the last presentations, we have to understand that refrigeration-based technologies are not a silver bullet solution. So Coolveg is an organization who created forced evaporative cooling chambers. These are the ones that Thijs was showing, which use the evaporative effect, but also fans to provide cooling. I know that Eric, the founder of Coolveg, will have a presentation later in the day, so he will explain these more in detail. But I just wanted to say that this innovation and this less focused on refrigeration technologies are many times important for other value chains such as fruit and veg. I just wanted to end the presentation by saying that all these innovators have done a great job at iterating and piloting their business models and doing innovative technologies to provide cooling services, but innovation is many times not enough. And these innovators need an enabling environment that supports them to scale and grow. And designers and stakeholders such as ourselves need to try to take an ecosystem approach. So I'm about to go on time, but I wanted to present that we just launched our Kenya Cold Chain Accelerator, which tries to take an ecosystem approach to provide support to innovators, not only through funding, but through additional support, including technical assistance, research, workforce and skills and initiatives, and creating a cross-sector dialogue between private and public sector, a platform for companies to express their needs to other stakeholders. You can learn more. You can scan the QR code or contact us in any time. But I wanted to finish up with that, and that we can all collaborate to try to address this issue.
So much, Florencia, for this very nice insights in all the work you have been doing. For the sake of time, I only have one question for you, same as I asked Bas. If you would have a magic wand and you could change something in this entire ecospace, what would that be?
That's a difficult question. And I do think that the magic wand would provide the specific solution needed for each different stakeholder, but in a more realistic wand, I think the creation of better awareness, as Bas was saying, of different stakeholders, especially development actors or financiers, of how to improve the deployment of these cold chain solutions and these innovations would be the one that I would use.
Great, thanks a lot. So it's good that we have this day that we can enlighten ourselves and get a better understanding of this. Great, thanks a lot. So then I would love to thank you again and shift to the next speaker, David from Innovex. David, welcome. Thanks a lot. I would love to hear a little bit your insights on this topic. So please go ahead and let's dive in.
Thank you very much, Thijs. I hope everyone can hear me. My name is David Tusubira. I'm the CTO and co-founder of Innovex. Innovex is a Ugandan tech company, and we leverage IoT in the distribution, operation, and maintenance of off-grid equipment. That includes cold storages, solar freezers, solar water pumps, and solar maize mills. Our experience with the cold chain has been through a number of projects. One of the first ones being the Off-Grid Cold Chain Challenge of 2022. Some of you might be aware of this. This is a competition. It's an annual competition where different cold storage manufacturers, showcase their cold storage product and compete and win based on the efficacy of their solution. We are also a remote monitoring solution provider for Coolbox. Coolbox is one of the biggest freezer distributors in West Africa. And just recently, we received a grant from the Efficiency for Access ecosystem. The essence of this grant was to develop predictive maintenance technology for off-grid appliances, including solar freezers and cold storages. So I would like to start by just mentioning what kind of value remote monitoring, especially in the cold chain, can bring. Of course, a lot of these applications and of course cut across different off-grid appliances and different kinds of off-grid equipment, but specifically for cold chains, remote monitoring can serve distribution. As we all know, affordability can be a challenge, and therefore you need to deploy different kinds of models like pay-as-you-go, pay-to-use, or pay-per-use. And remote monitoring gives you the ability to execute these models more effectively. The other thing is usage optimization. So we've developed technology that enables end users of off-grid appliances to optimize usage or have more energy efficient usage by leveraging weather forecast data. This is primarily to basically optimize the sizing of the energy system of some of these appliances. So if you want to have the smallest possible solar panel and battery bank combination, you can actually leverage weather forecast data and historical usage data to optimize usage and have the smallest possible energy system, therefore reducing costs. Of course, there's predictive maintenance. So this is basically the ability to be on top of maintenance and predict when something is going to break based on different patterns that you pick up from the performance of the appliances, in this case, a freezer or cold room. DMRV. So of course, given that a lot of cold chain solutions are solar powered or renewable energy powered, there's an opportunity to increase affordability through carbon credit revenue. And remote monitoring enables the acquisition of carbon credit revenue by evidencing usage and conversion. The other thing is food product traceability. So consumers of food products that go through the cold chain want to know that the product was preserved well. And one of the ways that you would achieve that is by having data or a paper trail showing that these products have actually been through effective preservation, and that's you can achieve with remote monitoring. And then of course solution sizing through usage tracking. So there's been a lot of mention about product market fit, and if you want to have a very good part of having good product market fit is sizing the product for that particular market. And one of the ways to do that is by using remote monitor or historical performance data to confirm whether the solution that was deployed is actually appropriately sized. And with that data, you can refine the design to meet the consumers of the product. So in our experience developing remote monitoring technology, especially in the cold chain, we've obviously learned a number of things, and I'd like to just get into a little bit of those. One is obviously cost. So remote monitoring, is still something that is viewed to be kind of separate from the actual solution, because the actual solution is cooling, right? And remote monitoring is kind of separate. And so it's really important to ensure that the cost of the remote monitoring fits in the business model of the cooling solution, right? You don't want to have remote monitoring that is, relatively costly, because that will affect the business model, right? So you want to make sure that the remote monitoring system cost is a small percentage of the overall cost of the cooling solution, therefore fitting perfectly. Power consumption. So remote monitoring solutions do consume power, right? Because you're measuring all these things and you're probably uploading data to the cloud or something like that. So that consumes power, and that now gets into the energy economics of the overall system. Again, a lot of these cold storages are in areas without grid power. So you're running on a really tight energy budget, and therefore the energy consumption of the remote monitoring solution has to be almost negligible. It has to be almost negligible compared to the energy demands of the cooling solution, which is the main thing. Connectivity. You have to get this data to the cloud. You have to get it into a remote server. And if these cold storages are typically deployed in places that don't have great connectivity, so the remote monitoring solution has to employ clever techniques, protocols and data minimization strategies and local buffering to ensure that all the data that is of interest actually does make it to the remote server in time. Carbon credit revenue obviously is a hot topic. It's important, and of course, remote monitoring is key. But it's also important to note that typically with renewable energy, it's not a lot of carbon credit revenue that comes per kilowatt hour of energy, and therefore, for it to make sense, there has to be a lot of aggregation of solutions. So towards realizing carbon credit revenue to increase the sustainability of these solutions, it is important that the aggregation of different individual deployments is factored in to maximize the capacity to draw this kind of incentive. It's very, very important to do training and onboarding of end users, everybody along the chain, end users and distributors, right? Because you want this remote monitoring solution to work, and for it to work, you need the cooperation from all the different users along the chain, and not just the manufacturer of the solution. Of course, given that this is remote monitoring, you're drawing a lot of data from this solution, and this is data from the end users, data from distributors, and all these different stakeholders. So it's really important that data safety is factored in, and all standard procedures towards data safety are adhered to. Now, predictive maintenance and all the different kinds of analytics are definitely possible, right? You can definitely do predictive maintenance. You can do all kinds of analytics to predict weather, and optimize usage, and power consumption and all that. But these things are very, very data intensive, right? So it's really, really important that is considered, and that goes into the economics of the entire solution. It's really important to select hardware that goes into the overall solution that fits within the model. But at the end of the day, if you want to do all these analytics, and if these things are genuinely vital, it's important to acknowledge that there's a lot of sensing needed, a lot of data, different kinds of sensing, like relative humidity, temperature, door state, compressor temperature, vibration, all these things. User interfacing is key, and what we've found is that typically users prefer receiving notifications as opposed to going onto dashboards, right? So typically end users do not want to have to go to a dashboard to see what's going on, or to get insights about performance of this application, of this solution. They want to they would like to receive a notification that is requesting action, right, or giving an insight, and them not having to log in. So it's important to note that, to bear that in mind. And then lastly, interoperability. Interoperability is key. You want these different cold storages and different cold chain solutions. There's a lot of variability in the type of energy solution, the energy of type of powering, type of cooling. These things vary a lot. So it's really important that the remote monitoring technology that is developed is highly interoperable with other systems, and that will make for a sector that is more efficient in terms of remote monitoring. And so it's really important that we establish standards that improve or increase, promote interoperability. That is it. Thank you, everyone.
Great, David. Thanks so much for your insights again. Could I ask you again the same question before we ask all the other people in? What would you like to change now, maybe in your field from your experiences? And then we can get all the other presenters in the meanwhile. It would be great. But what would you like to change with your magic wand?
Yeah, I mean, I would definitely have all manufacturers of cold chain solutions embed remote monitoring, or the foundations of remote monitoring capacity within the design of the cold storage, and that will reduce the need for separate remote monitoring entities to have to design for all these different kinds of cold storages. So if at least sensors are naturally embedded in the design, and therefore make it easy for remote monitoring to happen or to be done in whatever geography, I think that is something that I would change.
Great, good, thank you. So then we have all presenters now inside. Just before we continue, I just want to mention that we get a lot of questions on passive cooling. There is a session, I think number 7 at 2:30, which tackles that. So all the people interested there, please join. That I wanted to say, and let me start with a very relevant question which has been asked already a lot is, for example, apart from the viability of cold storage for different applications, what's the cost benefit of these, let's say, innovations here? So could anybody of the team, David, Florencia, or Bas, jump in? What would be the cost benefit of these innovations and how should we tackle that? Maybe Bas, can I direct this to you?
Yeah, I think Florencia gave a great example of the fishery sector where the income of the fishers increased based on the improved market access. So let us be clear that it's not only the technology, it is about that market connectivity, which is delivering the value for cold chains in this case. And if we dive a little bit deeper into kind of the cost benefits, for example, in the mango value chain, I've been working in Benin and Haiti on that, and we see like similar results, growing incomes from 2 times to maybe 5 to 8 times the income. But also giving room for other investments. Often farmers are looking into increasing productivity, for example, and having that market connectivity can make sure that there's offtake of the products, which can be really important as well. Small note, we also have to look into the different types of crops. For example, if you have potatoes, it's a seasonal crop which you produce maybe 1 or 2 times a year. So one important element for the cost-benefit analysis is, for example, the utilization of the asset. And that's often what is forgotten. So we look at a lot of food loss and waste, and we see it's happening, for example, in the tomato sector. And then there's a cold room being constructed for a seasonal peak. And for example, tomatoes can only be stored like for 5 weeks. So it's harder to make a business case solely on tomatoes in that case, also recognizing that they ripen after harvest. So cost benefit has many aspects. I can share a paper as kind of after reading for this webinar as well.
Great. Does anybody want to add on this, Florencia or David? If not, then we can maybe go to another question which came from the audience. And then the question came, for example, that in many African and Asian livestock systems, so we have a lot of, there's high dispersion amongst the smallholders, and people ask how decentralized cooling solution can help in these fragmented markets for livestock, but maybe also for dairy products and so on. So how could we have, let's say, cooperative ownership models or mobile cooling units? I think, Florencia, you tackled a little bit on this. Where do you see the potential there? In which direction should we go there in such decentralized livestock or dairy systems even?
Sure. Yes, we've seen good, successful business models and companies on the dairy sector specifically. And I would think that, or I would propose that advancement should go in 2 directions. One is the bulk milk chillers that maybe many are more aware of how they are. And they are the aggregators. They're located in the cooperatives, and that changed to a solar-powered bulk milk chiller. And the governance systems of cooperatives usually make it a successful thing, although it can also vary. But as an important point or gap for innovation is, as my example was saying, on the first mile. What about those farmers who are too remote from the cooperatives, can't provide cooling to their produce for the first hours or on the evening milk. So that's an important gap for cooling, and somewhere where technology and business model innovations can advance.
Thanks a lot, Florencia. Thanks a lot. So then I have a question for David, which came up. So if we want to ensure, let's say, long-term adaptation of these technologies so that they can be installed or being used over several years successfully, which is also often important to motivate it financially, what would we need? And maybe it would be great from your perspective if you can give a kind of a lifespan of these systems. So how long do you deploy normally at a certain location? What should we all take into account for long-term deployment and so on? What would your perspective be, David?
Yeah, so long-term deployment, of course, highly relies on, it's highly affected by sensor accuracy. So, sensors accuracy drifts off over time. So typically, the initial calibration of the system will probably last, 3 to 5 years, minimum 3 years, maybe 5 years. And so what you need is mechanisms of recalibration. It's possible to have auto calibration, but that's usually a bit complicated. So you want calibration of sensing to be part of maintenance. I mean, if you have a cold storage, there has to be physical maintenance, right? Somebody that comes in and maintains it. So that has to be part and parcel of it. How to make sure that these things are adopted, besides just being practical in terms of sustainability, it's very important that the benefits of these solutions are clearly communicated to the entire chain or the entire value chain. That's the end users and the distributors. Once the value of these solutions is established, then it's very easy to embed the sustainability into the regular operations and common practice.
Great, thanks a lot. So we will try to tackle all the other questions via the chat of the participants because we got many, many more. I would like to wrap up this session and thank you all for your insights you gave. There is a lot we have learned, but there is much more to learn from everybody. So thanks a lot for sharing this. There is a next session which will start at 10:30, so there is a 15-minute break where they will be talking about refrigeration choices, renewable energy integration, and technician training, and end-of-life equipment management, because we want to avoid additional climate burdens as well. Now, please, before this break, note that there is this Your Virtual Cold Chain Assistant onboarding kit, which can provide tools and learning modules to help you apply this framework step by step. So please have a look at that, and you can scan the QR code, which you see here on your screen. And apart from that, if you want to be updated about new developments here and also others, then you can be subscribed for the base newsletter, and you can also write with several questions on the email address which you see here. So we would please motivate you to do so. And now we're taking a short 15-minute break. You're welcome to stay, of course, and during this break, enjoy an introductory video on the project. And we will also continue to answer some questions in the chat. So thanks to all the speakers. I was very happy to have you all here. Thanks for all the participants, for all the nice questions we got, and looking forward to the rest of the day. Ciao, everybody.